Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Well, Houston, today we want to talk about igneous rocks. These are rocks that formed in magma, boiling, churning, hot liquid rocks. That's where they started, but then what did they become? So igneous rocks. Well, turns out there are two kinds of igneous rocks. There are extrusive, which you see right here, and there are intrusive. Now, think about those words. Extrusive means outside, right? The word ex. Intrusive is inside. Here's the deal. Those that formed on the outside of the earth, on the surface of the earth, are extrusive, and those that formed under the earth are intrusive. So igneous rocks can be classified in two ways, as either extrusive on the outside of the earth, on the outside of the surface of the earth, or intrusive igneous rocks. That leads us to a kind of a cool word. An intrusive igneous rock. Now remember, those are the ones that are underneath the earth are called plutonic. What does plutonic come from? That comes from the word Pluto. Pluto, if you recall, was the Greek or the Roman, I forget now, god of Hades, of hell. And where do you find hell in classic literature? Underneath the earth, where the hot fires of hell are, right? So here's a classic example of a plutonic rock. This is Yosemite's most famous rock, one of the most famous rocks in the world, El Capitan. People climb it, it's crazy, right? This rock formed under the earth, but it's now above the earth. We'll talk later how that happens. That's pretty awesome too. So this is a plutonic, or another word for an intrusive igneous rock. Another example, famous dude rock, right? With Washington, Jefferson, Roosevelt, and Lincoln. I'm reading a book about this guy, and I couldn't remember his name. And this is also an intrusive plutonic igneous rock that somehow came to the surface. That's just wild, but that happens. We'll talk later about how that happens. That's pretty cool. Let's talk about so as a note, these are the intrusive igneous rocks. Here's some extrusive igneous rocks. So these are ones that form on the earth. The most common rock in the world is this one right here. It's called basalt, B-A-S-A-L-T, maybe double S, I don't know. Basalt. It is found mostly at the bottom of every ocean. You're going to find this rock, boring black rock. This came up from the surface of the earth, and it melted on the surface of the earth, potentially even under the water. And this is a similar one. It's called obsidian. That's a cool one. You may have seen this. Obsidian is also called volcanic or black glass. It's very useful in making arrowheads back in the day. It's a pretty awesome rock. And these both formed on the outside of the earth. And now let's go back to the intrusive igneous rocks. Now take a look for a moment, actually. Take a look. If you look at these and you zoom in, you don't see in what we call crystals. Remember, crystals are minerals. But when you look at these are intrusive igneous rocks. You see crystals. You see got a black crystal here, kind of a big orangey crystal-y thing here. And this one is a mixture. You've got the brown one here, and then the pinky guy right there, and this more of a, I don't know, purpley pinky thing, whatever. So this is all different rocks. You might notice, so we have different sized crystals here, small crystals or no crystals. Here we have big crystals, or big-ish crystals, and that tells us something about where it formed, whether it formed under the earth, intrusive plutonic, or above the earth, extrusive. So that leads us to the crystal size. Now here's another cool one. Look at this one. Man, look at the size of that crystal. That is a monster. And here's, this one's got a nice cool face on it. So crystal size tells you everything. So crystal size is, you can either have small or no crystal sizes. This one, if you would like to take a magnifying glass, maybe even a microscope, you will see the crystals, the individual little crystals that are separate. So this would be a small size, right? And then, of course, this would be a big size. Now, here's the deal. If you have big crystals, all right, it's going to be intrusive. Why? It's going to be intrusive because what happens is it's going to cool down slower. And if it comes to the surface of the earth, because the earth is much, much colder than under the earth, it's going to have no crystals. Now, you might say, why is that? So let's say we've got the land, maybe a little mountain here, and under the earth we got a big chamber of magma, right? This is hot liquid rock, right? And over time, maybe it starts to cool. This area is cooler, and it can actually re-solidify. So maybe there's a source of the magma from deep under the earth that's feeding this magma chamber. But over time, the source dies, so to speak, and now we still have this hot liquid rock, and it slowly cools, slowly cools, slowly cools. But something interesting about chemicals is as they slowly cool, they cool slow enough, then chemicals, or compounds, I should say, of like type will get together. They like their own kind, I guess. That's a weird thing to say, I mean, but it's what they do. So these crystals like the same elemental compound, and they will then migrate towards each other, and they will have time to make a crystal, okay? And you'll get larger crystal sizes, and maybe you'll find a bunch of this right kind of crystal and be very rich and be in something that's valuable for the planet or for making things or whatever. And so if it cools slowly, that's an intrusive igneous rock, and so therefore you're going to get large crystals. But if it somehow makes it to the surface, like this one, that, you know, same picture, right? Boom, got the magma chamber, but somehow it escapes to the surface of the earth, it's going to cool, and you're going to have either very small size particles or very big size, or just going to be small or even no size particles. So the size of the crystal of an igneous rock tells you if it's either extrusive or intrusive, or better known as plutonic. So that's video 1 on igneous rocks. We got more to learn about igneous rocks because Houston, we are solving the problems. See you in class.